Hi everyone, all the previous videos led to this one. We will now finally be creating a smart object for BPSO treasure chest, and we will create an enemy that will find and claim the smart object, and most importantly change its behavior based on the smart object. So let's get into it. So before we go into implementing it in Unreal, I thought I'd just do a quick 5-slide presentation on smart objects and state trees, just so you can understand conceptually what's going on. And I don't feel like other tutorials do this enough, so I wanted to do it just so explain what I think is happening. Okay, so this is essentially how these two objects interact with each other, but before we go in, let's talk about just state trees. So the way it works is you have an AI controller, and that serves as a brain for the pawn. So this would be your third person blueprint, or sorry, enemy character. It will have an AI controller, which is its brain, and it can handle all the perception, including visual, sound, and damage. And once it picks up on this, it sends an event to the state tree. The state tree runs the logic. So let's say it sees the enemy, then the state tree will pick up on that event, and then it will go to that enemy and attack it. That's what it will say. That's what its reasoning will be, and it will tell the pawn to do that. So the pawn is like the set blueprint character, and it basically reacts based on state tree information. So yeah, that's how you should think about it. So yeah, brain, logic, and reacting actor. Now, on the other hand, smart objects, they have something called a smart object definition. Now, this is just a template, and it's created before runtime, and it's just basically defining where the interaction slots are, and what specific behaviors the agent object can take. Now, the smart object actor, that's what we're interacting with. In our case, it will be the treasure chest. This is what our NPC will interact with. And then we have the smart object behavior. Now, this can be a lot of things, but this is how the agent will react when it gets to the smart object and what it can do. So it could be a gameplay behavior config, montage, behavior tree as well, but we're going to be using state tree. And what happens is once the NPC reaches a smart object, it has to claim it, and then when it interacts with it, this state tree is essentially paused for a while, and it's replaced with this behavior here. So what it is saying is, forget about the state tree, use this instead for a while, and then once this is completed and it is released, the smart object is released, this state tree becomes active again. And whilst the smart object is active, it has two context characters, which are the pawn agent and the object actor. When the state tree is active, it has two context characters, which are the AI controller and the pawn agent. So effectively, when the behavior is active, the AI controller is not in use, so it can't really sense what's going on in the environment, if that makes sense. But this is only done when it's replaced when it's claimed, so yeah. Now, state tree execution flow. So the way it works, and this is just you have first of all the context. Now this will be the actor and controller, and sometimes you have some subsystem handles, but you just have those two, mainly the ones I use. Then you have the evaluators, which are basically checking sensors, tags, distance. After that, then you have the selectors. Now, state trees will always go from roof node to the first available leaf node that it can go into. So it will try and pick the first one that it has available, and then once it is in that state, it will complete all the tasks that are in that state. And tasks are where you spend 75% of your time creating them. And you have to make sure they have enter, tick, wait, finish, and abort. And you want to make your tasks small and well defined, and design explicit completion, cancellation, and cleanup pathways. It's very important, these tasks, that they have a finished task node. So it's very clear that once this task is complete, it can move on to the next thing. Then finally, you have transition. So transitions are where you move from one state to the next state, and this can be based on a lot of things. It can be based on the AI controller saying, here the the perceptions component has been updated. So let's go to the investigate state or detect state, or it could be on this task being completed as well. There's a lot of way that transitions happened, but yeah, this is just a general context on how state trees work. Now, smart objects, they have the what I call the interaction pattern. So the way it works, you have this one specific task, which is called find and claim smart object. Now it starts off with a need by the agent, so the our AI NPC needs a weapon, so it's going to go into that state. Then it sends out a query and a query area where it says we're looking for this smart object subsystem. So we're looking for a smart object, and it tells the smart object subsystem to find it by its query criteria. Once it's found the criteria, it claims it. At this point, when it's claimed, that slot is off limits, so no other AI NPC can claim that slot, and that means that you won't have two NPCs accidentally claiming the same smart object at the same time. All slots honestly, it's a queuing system, but it makes sure that no other NPC can basically reserve that slot whilst it's being claimed by this one NPC. Now, there's another part. So I say act, but it's first of all it's moved to and then act. So once it's claimed, you have to move to its slot location, and then you can do whatever the NPC is telling you to do. So play an animation, grab a weapon, etc., etc. But some sort of gameplay action happens here. Then we release it, and whilst in this claim and act state, well, actually it's more in the act state, the gameplay behavior is changed from the NPC state tree to the smart object state tree. And then once that's done, we release that smart object, so it's now refindable, and other NPCs that can find that slot, and the NPC's state tree goes back to its original one. Now, I just thought I'd do a little bit of just state tree versus behavior trees. So both can drive AI, but they organize decision making around different control modes. So state trees, they have run on the active state branch with explicit transitions. They're very, very clear, and that's why I like them, because you are in full 100% control of how one state goes to the next state. The grateful modes, interaction, reservation, and cleanups, as you'll see throughout, we can easily get a smart object, and then we can make sure that it only does what it's supposed to do in that area. And one thing you need to be clear, and this is because you have 100% control, you have to make sure that the states are very clear. You have finished tasks throughout, and the transitions all make sense. If you got any vagueness in the state trees, that might work against you, and you need to be very clear about what state goes where, and the logic makes sense as well. Sometimes I've seen very illogical state tree diagrams, which I'm like, that doesn't make sense, and then that produces weird results. So 100% control, but then it's on you then to make sure it's correct. Now, behavior trees, it selects the highest priority runnable branch, so you don't really have control on where it's going to go. You do, but it's like in a different way. The strengths, they're not really good for anything. I can't think of any reason why you would choose a straight behavior tree. And you need to watch out, because the decorator and service logic can obscure why controls change, and you have no control over the state transition. And worst of all, you have to use a blackboard, and you can't access the AI control endpoint directly. So it's the constants of trying to get something into blackboard, get it back out, and create lots of variables. And it's a very, very bad system, and you shouldn't be using it. And a core shift is behavior trees ask what can you run right now. State trees ask what state owns this behavior and how to run it. And so I think you can all agree, smart objects rule, behavior trees suck. Behavior trees, let's reject them. If there's anything you can take away from this presentation, is you should never ever use behavior trees. They are the worst. You have seen the light, and you're now all going to adopt state trees. Okay, let's jump into Unreal and let's get started. Okay, so last time we basically got to the point where we had our BP treasure chest, and we basically created such that we had a weapon manager component system, and the treasure chest could be interacted, and then we'll play this sequence, get the treasure chest, and it would draw a weapon, and then you could run around with the weapon. Now we're going to do it with the smart object part, and first of all, like we saw in the presentation, so we need a couple of things to make it so that an AI NPC will go to these, find these chests, pick up the weapon, interact with it, pick up the weapon. So let's create a new folder, call it enemy. Now we'll need a couple of things just to get started. First things first, AI controller. We'll take detour crowd controller. This is supposed to mean that basically different AIs don't run into each other. And I'm going to name this AIC enemy. Then I'm going to have another blueprint class. It's going to be a class. It's going to be called BP enemy base. And yeah, so this is for the time being just going to be Manny. So let's just get him in. Manny simple. minus 90, ABP unarmed. We want to give him the BPC weapon manager component that we had from last time. So this will allow us to interact and get a weapon. We also need to change the AI controller. Class defaults. AI controller. So we'll change it to AIC enemy. And finally, this is just so, because we're not using a player controller, we need to tell it to use acceleration as movement. So it acceleration for path, and that will basically ensure that our animation, the walking and running, will be played. Okay, now I'm going to create another folder. I'm going to call it state trees. And for the time being, I'm just going to create one state tree. I'm going to call it STAI component schema. ST enemy and yeah, before we begin, I'm gonna then add the state tree AI to the AI component and just give it our one and only state tree in there, and compile, save. And actually, I'm just going to check that it's going to be start logic automatically, so it's not good. It's basically the start logic on begin play, which is what we want. Now we're gonna change the context specific to our characters. So first of all, AI controller is AIC enemy, and BP context is BP enemy space. Now you have the evaluators and global tasks. So evaluators are done on begin play, and global tasks I think are done on tick, but I may have got them mixed up. The parameters are just variables that are accessible to any task in your tree. So the left hand side is for global stuff, the right hand side, the details, is for specific stuff. So I'm just going to remove this. You can then add new states, new conditions, and new considerations. Considerations are basically like conditions, but conditions are true and false. Considerations give you a float value. So if I remember that correctly. So yeah. Now I'm going to create first of all, a simple state just to now check everything's working. It's going to be called print. Now, so we're just checking that everything is working right now. So I'm going to create a new state tree blueprint class. I'm going to create a folder, call it tasks, and this will be stt print string. Now, when we get it, we have to override, so have an enter state. Then we can add the variables that we need. So for state trees, they come in various packs. So I can have string to print. Now that's going to be our main one, and I'm going to change this to a string. Now you have the context input and output, which are the three types. But you also have a force type, which not many people talk about. So if it's an input, then it basically means it's a binding. So let's come to category type input. Now when I add that to the state tree here, you will see it's an in here, and what this means is it has to be a binding somewhere. So this means, what I mean by binding is it's either taken directly from the AI controller or BP enemy base, or is from one of these parameters here, or you previously got it from some state before. Now in our case, we don't really want it to be an input. We want it to be sort of, because we want it to be on, like, just exposed as a value. So I'm going to change this back to category, or the default one, and I'm going to make this exposed on spawn, and now we can just type in anything we want here and it'll get printed. So I'm just going to say testing for now, and that will basically mean we get this here and we do print string, get the value, and that should work. Now, with like blueprints, you need to tell it when this task is completed, and we do that all by searching for finish task. If it's successful, if it's not successful, we just make it very, very clear, and this will basically ensure that this task is completed and it can go on to the next. It can go on with its transitions. Now, if you look at the state tree here, you'll notice that there's various types. You can have got state, group, linked asset, subtree. Now the main ones you'll be using is state and group, and the idea is when you add a state and add a leaf node, if you had a task in here, it might not happen because it goes to the leaf node first. So all these middle tasks should always be, these are leaf, and these should be the parent group. The idea is this handles the conditions of like coming in, so you can have conditions here, and it also manages the transitions going to the next one. So for example, this STT string, I'm going to say on state completed, go to the next selectable state, which will be parent group, and here I'm going to add another task, which will be this is leaf node, and then I'm going to add a transition. Well, when this task is completed, I'm going to add a transition to the group, which is basically going to be saying on state completed, a tree succeeded or a tree failed. That means this entire tree has been completed. And it will go to, and this one, yeah, we can do the same thing, to be fair. Actually, yeah, we'll just go, it's not going to matter. Actually, I'm not going to delete it. Yep. So, let's test this out. And, sorry, this should not be a state, this should always be a group. So groups aren't allowed to have tasks, as you can see in them, and that's the whole point of it. So it should be groups within leaf nodes within groups, and you go through the leaf nodes having various enter conditions and etc. So we'll come to a specific enter condition when we come to our example. So yeah, got state tree in there. Let's see if this works. Also, I'm just gonna add, just before we load in, just the nav mesh, because I will always forget it. So nav mesh bound volumes. I'm gonna do it 0, 0, and then I'm gonna just make it, I just need it to cover everything, so I'm just gonna go up to 20. Oh, look at that. And it covers everything, as you can see. Also, all the parts in green are now accessible to my AI characters. So let's just put him in. And I'm just going to turn off the nav mesh by pressing P, just so I don't need to be in there. Okay. So yeah, testing comes first. This is a leaf node, comes second. So yeah, it's printing how it should be. Okay, so let's just jump into let's now create the smart object for it to find. So we're going to come to our treasure chest. I've already created a smart object folder. Now, if you remember my presentation, we need if you haven't got this already, sorry, because I had the plugins done, you're going to need AI behavior. That's the gameplay state tree should already be done. Gameplay interactions. Yep, this one. And then smart. Yep, these two. So you need in total 4 plugins for this. Yep. So I'm going to create a smart smart object definition. I'm going to call this SOD treasure chest. Now the object class will be the BP treasure treasure chest. I'm going to just save it, and the object path will be treasure chest. You could use your own objects here. I'm not going to use the user class. Now I don't know why, but I find it's normally supposed to pop in there, but it doesn't. And if you do, just close it, reopen it. Don't know why. It should just do it, but I guess it just doesn't. Now, what smart objects does is it basically, this is the object, and it needs to know the slot of where our enemy is going to go. So we're going to come up here, and we can add a slot. Now, to be fair, you can add as many as you want, but if you had a table or a couch or something, you'd have 3 slots for each seat. But in our one, I'm sure you can agree there's going to be one slot is only needed. So I'm going to just remove slot, remove slot. Now, I'm just going to rename this. Oh, sorry, I have to rename it here. Enemy location, and I'm just going to change the color to red, just because I want to. Has no difference whatsoever. Now, actually, 110 is not bad. So if you remember from our last tutorial, our level sequence works, and it basically says that the character needs to be 120 units away from the box. So I'm just going to put this 120. Now, you can tell quite quickly the arrow's facing the wrong way, so I'm going to change the rotation to 180. But there is one thing I'm also going to add. So this needs to be reachable, like in the nav mesh. This slot needs to be reachable and found, and it needs to be the AI needs to know that it can reach this spot. Now what happens is sometimes the slot is really just touching the floor, and it's sometimes just underneath the floor, so it's always going to be unreachable. So we're just going to push it up by 10, and that way it's just off the floor. It's a little thing, but trust me, you will spend hours. Oh yes, I need to provide it with behavior. Sorry. You'll spend hours trying to work out what's wrong with this smart object, and it's just touching the floor and it can't find it. Now, user tag filters. So what are user tag filters? Now, Unreal's documentation says that this is kind of like the lock, and the user, the BP enemy, has the key to call it. I like to think of it more as the name of the smart object, and that, you know, when you go and find the smart object, you're basically calling out its name. That's how I think about it. That's how I'm going to look at it. So I've already created a smart object treasure chest tags, but if you didn't, you just go here, add sub tag, and then just write in treasure chest. But I'm just going to put this in there, so it's there. And now activity tags, this is mainly used for the gameplay ability system. I don't use a gameplay ability system, but I know you can assign tags, so if you're interested in that, please do that. I'm just not the best at that. If I'm being honest, I'm not really good at gameplay tags, and my hierarchies are always just like, I need this tag, let me put it in there. I'm not really the best at it. Okay, now here's the most important part and why we do smart objects. The definition, behavior definition. So like I said in my presentation, the whole point of a smart object is to basically stop the AI from doing what it's doing and do what the smart object is telling it to do. Now we come to here, and this is the user behavior definition. Now, before the gameplay interaction, we had to rely on this behavior smart object, which basically gave us access to a config file, a config information, which is basically just play montage, or we had to create our own behavior tree, even though this is designed for state trees. Now, post gameplay interaction plugins, we can use this gameplay interaction smart behavior, and that now we have so we can access a state tree, but it's a specific type of state tree. It's not our AI state tree. It's actually going to be a gameplay interaction state tree schema. Now I'm going to call this ST treasure chest. And by the way, feel free to come up with better names. I'm not the best, so yeah. Now this one here, I'm going to just call it, what am I going to call it? The enemy type. The smart object actor is the BPSO treasure chest. And notice we're basically abandoning the AI controller here. The AI controller is replaced by the smart object actor, and now the smart object, this state tree, is in control, not this state tree. So that's the whole point. If you had, you're probably wondering why you would do this, but imagine if you had like 5 or 10 smart objects. You'd have one interaction find it, then let this state tree take over. Otherwise you'd have to create 5 different state trees just to interact with one thing. but yeah, that's why we do it. Now, first things first, let's get rid of this and this as well, because we don't need it. So we're going to add a new blueprint base condition, and this is going to be STT find smart object. Now this, I'm going to be honest with you, is pretty standard, and I'm just going to write here find claim and use smart object. Now the enter conditions. Okay, so let's just get our variables. So BP enemy, and that will be BP enemy and I'm going to change this to context type, so automatically be bind. And now I'm going to change this to AIC enemy, and can you guess what type this is going to be? Yep, AIC enemy. And I'm going to change this to context as well. So we have access to essentially these two values here. And in fact, let's just add it in, find and claim smart object. And we're going to get the task, find and claim smart object. These two, can you see they're already bound to the items that we need? So, you know, they're already there, saves us a bit of time. Now, let's get the smart object subsystem. Find smart object. I'm going to find all of them, just in case. Then I'm going to, the user actor will be the BP enemy. Then I'm going to do make request. Now the query box is essentially the size of, like, how big the radius is, the search radius is. So I'm just going to make box with origin, and the origin will be our BP enemies actor location. Get actor location. And the extent, I'm going to split this out. Now, if you may remember from our last level, we basically had the secret location here at 000, which is where our characters and all the weapons and everything is going to spawn. So I want to make sure, and technically this is a smart object, but I don't want it ever to try and find this smart object. So I'm going to just limit the Z to 750. And the X and Y, I'm going to just promote variable quick search extent XY. And I'm going to make this exposed on spawn so you can change the value in the smart tree, and I'm going to set it to 2000. So if we come here, it's 2000. If we need to extend it, we can make it bigger, but I think 2000 should be way more than enough. Now we're going to make smart object filter. Now, yep, so activity requirement we're not going to use because that's mainly for gameplay ability system. I'm going to search for call out the name of our smart object, which is the treasure chest. It should evaluate conditions. we don't want to include claimed spots, and we don't want to include disabled slots. If you are for some reason ticking this, I'd really question that, and I don't think you're using smart objects the right way if you're claiming claimed spots, because that means that essentially you're defeating the whole point of using a smart object. And smart objects fundamentally are just a queuing system. They ensure that once an NPC claims it, no other NPC can claim it. So that's really why we're using it, if I'm being honest. Okay, now you're going to be one. So this is the result of all of our smart objects that is found. Now, first of all, we're going to basically say, if it's false, then it's found none. So we're going to say print string no smart object found. Yep. But if it is found, we were going to take one. Now you're going to be very tempted to basically want to find the nearest smart object, and that's actually, it's a lot harder than it should be. And I'm going to recommend that you look at Unreal Shinobi's tutorial on making AI actually use the smart object. He's got a whole 15-minute talk about how to find the nearest one. Well, sorry, actually 10 minutes. He's a fantastic channel. He does great C++ stuff as well. So yeah, check him out, and he will do the find nearest one. I, on the other hand, will unfortunately just do random array item, which will be just the random array item. Now we're going to split this out. Actually, I'm going to undo that. I'm gonna break just so it's cleaner, because the random sometimes looks over. Now, if you remember, we had a smart object handle and slot handle. Now, there can only be one smart object handle, which is the only box. We can have multiple slots, so I can add like 10 slots here. Yeah, so that's why there's 2 of them. Now I'm just gonna get rid of this and apply and save. So I'm going to get the smart, I want the slot handle, and I'm going to do claim mark smart objects as claimed. Oh, now claim priority, that's, first of all, user actor is BP enemy. Let's say you had a boss AI and you had a normal henchman AI. Now, I'd argue that the boss has more priority over the henchman. So you can do different priorities depending on who's applying for it. So if it was the boss, I'd put him at high. Henchman, I put him in normal. So you can just, it's just about, giving priority to those who need it, let's say. Now, claim handle. We're going, so you basically, then you want to use the claim, so once you've got the handle here, you basically want to use the smart object, and you want the smart object, you want to basically make this treasure chest take over. So if you use smart object with gameplay behavior, that was the old one, and that's basically without play, but we want the smart object with the gameplay interaction. That's the new one for the state trees. So just so we're clear, if you're using gameplay smart object behavior, then you use the first one. If you're using the interaction smart object plugin, you use second one. But there is a caveat here as well. So if you just get rid of it. If you just did this like this, it would literally take over the smart object from where the BP enemy is standing, and we never want that. We want him to first go to the slot handle, then start interacting. So we're actually going to use this move to and use smart object gameplay interaction, and we're going to get the AI controller, add it in. Yep, And here is lock AI logic. This is probably the most important boolean in smart object interactions, because what this basically says is lock this state tree, our enemy one, and now used this state tree, which is our treasure chest one. Now, if you untick that one, what would happen is it will try and run both at the same time, which can create some very funky results, and I actually don't know what would happen there. Okay. So when it's finished, now on finished, we can do finished task. I'm gonna say it succeeded. Well, actually, I'm gonna do it on succeeded, but if it's failed, then we basically say succeeded, failed, and we can. Well, actually, we'll also do it for here as well. So if we can't find one, or for whatever reason it's not being able to claim a smart object, we'll say it's failed and move on from there. So that's now should claim it. So let's just come here, and before we even do anything, let's add a print state, and let's just do the task of print, and I'm going to call it using using smart object state tree. And I'm actually going to change this slightly. So if you look at this value here, now this is probably a godsend. So what used to happen was in the past, in like 5.4 and 5.5, is we can only have one task which I can say if it's finished task or not. And if you want to do multiple tasks like this one, like I want to add a delay task in here, then if both of these are ticked or highlighted, it basically means the first person to send off a finished task basically says this task is finished, moved on to the next transition. So we don't want the print string to say that. We want to delay for 3 seconds, 4 seconds, and then once that's completed, we will go on. And just to be honest, just so we understand, right now what would happen is if we got to the state tree, it would print, then go back up to the root, print again, go back up to the root. So what Unreal does is we need a transition here, and on state completed we have a tree succeeded, tree failed. Tree succeeded basically, or failed, means that we tried to complete this tree, we can't do it, and now we're just going to stop it, or complete it's succeeded and we're stopping it. So yeah, likewise, let's come to SM enemy. So we're going to find the smart object, then we're going to create a transition, let's call it print, give it a task, it's going to be the print task, and I'm going to say back to original tree, and I'm going to transition to on state. So we can, if the finished task is true, then it's succeeded. If it's failed, then it's failed. If it's false, then it's failed. But if you've got a finished task in it, then it's completed. And I'm gonna say next selectable state. And likewise with the tree, I don't want it to like go back to the root and then try and find another one. So I'm going to do is transition, and on completed, the tree selected, tree succeeded, sorry. Okay, so I've got this here. I'm gonna save it. Oh, and I need to add this to the enemy base. So let's just yeah. Where's BP treasure chest? Smart object. Oh, sorry, I pressed the wrong button. Just gonna do that again. Smart object. Enter. And I'm literally just gonna give it the only one there, which is smart object. Now, if I've done this right, what's this happening? Yeah. So it's the enemy location was this one here. That's why it was going there. But yeah, you can see now if I click on them. So here's the smart object rotation, and so on. So let's just see what happens. Smart object tree comes in, and then we wait, and then goes back to the original, which is what we wanted. Let me just make it just a bit longer. Yep, the duration. Let's make it about 5 seconds, just so it's super duper clear. And I'm just going to control shift save everything. So we come in. Yep, using smart object state tree. 5 seconds. And then we're back to the original state tree. So yeah, and we're standing in the correct spot as well. Congratulations, you have created the main structure for the smart object. Your NPC can now find and claim a smart object, then it will change its behavior according to the smart object itself, and then finally it will return back to its original state tree. In the next episode, we'll be adding our animation sequence to the state tree itself, and then something I think is really cool, we will be stopping the NPC from finding our smart object if the player is near, and I think that's a very good ability for our game. Thank you, see you in the next one, and remember, this is just my way of finding smart objects, not necessarily the right way.